Section 4.7 L'Hopital's rule. This section we will see another application of the derivative as we use it to find the limit of the quotient form. Indeterminate form 0 over 0. Suppose f and g are differentiable on an open interval I containing the point A with the g prime not equal to 0 on I when x not equal to a. If the limit of the f equals limit of the g equals the value 0 as x approaches a, then the limit of f over g as in a form of the 0 over 0, which is called the quotient indeterminate form as 0 over 0. We can apply the L'Hopital by finding the derivative of the numerator divided by the derivative of the denominator and take the limit. Example, evaluate the following limits using L'Hopital's rule. We have the limit of x squared minus 2x divided by 8 minus 6x plus x squared. As we do the direct substitution, we would get 2 squared minus 2 times 2, which is 4, divided by 8 minus 2 times 6, which is 12, plus 2 squared, which is 4, and gives us a 0 over 0, which is called the quotient indeterminate form. Apply the L'Hopital. I put the notation L on the top of the equal sign as a reminder that this step we are applying the L'Hopital. By finding the derivative of the numerator divided by the derivative of the denominator to get the limit of the 2x minus 2 divided by negative 6 plus 2x as x approaches 2. And then we can try with the direct substitution to see if the value come out as the real number or not. So 2 times 2, which is 4, minus 2 of the as a numerator, and denominator becomes negative 6 plus 4. Or we get 2 divided by negative 2 or negative 1, which is the real number, not in the indeterminate form as a 0 over 0. So then the answer for this limit is negative 1. This example, we have the limit of 1 minus natural log x divided by x minus e as x approaches e. Check the value by doing the direct substitution to get 1 minus natural log e divided by e minus e. The numerator is 0, denominator is 0. So this is the quotient indeterminate form of 0 over 0. Apply L'Hopital by finding the derivative of the numerator divided by the derivative of the denominator. Then we get the limit of 0 minus 1 over x for the numerator and 1 minus 0 for the denominator as x approaches e. Simplify to have the limit of negative 1 over x as x approaches e and replace the value of the x with the value e to get negative 1 over e as the real number solution. So the limit is negative 1 over e. This example, we have the limit of e to the x minus 1 divided by x squared plus 3x as x approaches 0. Check the value again using the direct substitution. E to the 0 minus 1 for the numerator, 0 plus 0 for the denominator, or 0 over 0 as one of the indeterminate form of the quotient as 0 over 0. Apply L'Hopital. Limit x approaches 0. The derivative of the numerator divided by the derivative of the denominator. Then we get e to the x divided by 2x plus 3. As x approaches 0, replace the value to get e to the 0 over 2 times 0 plus 3, result in 1 over 3 as the real number. Example 4, limit of the 3 times sine of 4x divided by 5x. As we check the quotient by replacing x with the value 0, get 3 times sine as 0 divided by 0. or 0 over 0, which is one of the indeterminate form in the quotient form. Apply L'Hopital. Limit x approaches 0. The derivative of the numerator divided by the derivative of the denominator. Then we get the limit of 3 times 4 times cosine of 4x by applying the chain rule divided by 5 on the bottom or for the denominator. Take the limit as x approaches 0. So we get, since we know that cosine 0 is 1, so we're going to get the result as 3 multiplied by 4 multiplied by 1 divided by 5, or 12 over 5 as a result.